the purpose of this video is to run through the DC block inside DeltaV, and what I'm going to do is focus in particular on a valve, but it's essentially a block that's vital for understanding, especially when you're doing commissioning and validation of different items. So essentially the DC block acts as essentially a way of looking at inputs and outputs and then confirming that state is the way that it actually should be. And there's many people who will execute, say, for example, documents like this here. It's like, say, for example, we've got an operation verification sheet, and you might have a reference to certain, variables which are there, but there's an issue often that many of the variables that are there in the background, they're not actually fully understood. And I think it's essential that you actually can understand them, especially when there's going to be tweaks made to the variables over time, such as, say, for example, if you look at the simulate input here, you'll effectively find that you might have lots of interlock conditions going on, but those interlock conditions are not actually being challenged when they actually should be challenged. So that's why I feel that a broader audience should definitely have an understanding of these things here. So essentially, there's actually a great picture here of the DC block specifically itself, effectively saying that there's the logic in the background. You can't open the block properly to actually look at the software behind it in the way that you can with other items. But essentially what I feel is needed is an understanding of these items here. Okay, so one of the first ones really that really kind of jumps out, and I think it's the most basic, is the state masks. So the state masks are essentially going from true to false to a very large extent, and passive essentially means off, like a motor not running, right? And then essentially active means that you are actually running. Now, the best way to describe that would be, say, for example, if we have, say, for example, like I have a valve right here, and it probably can't be seen easily. There's a small wiring diagram here, but essentially what you have is the whole idea of a reed switch for open, a reed switch for close. So we have some kind of inputs that we can bring back. And then we have, say, some spare inputs here, which aren't actually used in the logic at all. And then we only have one output. So say, for example, some kind of a relay, which it basically allows pressurized air to go to a valve so it opens, for example, right? Or in the case like this, say, for example, it's a motorized valve, right? And essentially then what we have is, say, we have items here, like, say, we have the actual time it takes to get to active, or the time it takes, to get to passive, to basically open a valve or to close a valve, and what's actually, allowed in that sense, right? So the other aspect here then, I think, which is kind of, fairly important, which is the whole idea of where the inputs and outputs actually come from. So here, say, for example, we can see that there's F in one, D1 and D2. And many people can get kind of confused on those. And essentially what they are is they're temporary variables, which effectively get passed to kind of this input 1, input 2. Then we have, basically into the outputs again, and we're back again to our state masks. Okay, it's kind of hard to explain. The best way that I would probably do it is I would go to, say, for example, if I go here, and essentially I'm looking at kind of like a loop drawing. And essentially it's when the actual logic comes back itself, you're kind of determining the inputs and outputs again. That's kind of the way to put it. You've got variables, and then basically they get passed to variables that hold it for a long period of time. It's difficult enough. But essentially, probably one of the number one items not to have enabled when you're getting serious is essentially the simulating. Right, so simulating basically bypasses a lot of different issues, including alarm states and so on, which is definitely a kind of a big problem. Okay, so look, what I'll do is I'll do kind of a practical example of the DC block in action. So essentially I have a valve here, and I'm going to open up his faceplate. And also then what I have is I have a live cabinet here. So here, say, for example, what I have is I have a valve, and that valve is essentially he's closed at the moment. You can see it because you can see red on top. And then if I just move him across, then you'll see as well that there's these two relays. It's actually kind of hard enough to see, but one is for power on, and then this relay right here, he actually basically sends the actual the valve open. Okay, so what I'll do there is I'm going to go in to an application that I have open, and I'm going to send basically a message to his variable. So I can actually do it directly through Control Studio. So I can go in here and I'm going to set the value to 1. And then what I'll see is on the actual screen, I'll see him he's opening, and he's only set for 10 seconds. And if he doesn't open in 10 seconds, then we end up with a real problem. And I can see he's alarmed, but he's actually turned almost from red to yellow. And then as well over here, I can see that the relay has actually gone on. Okay, so he is actually working. And it's an example there of being careful with settings that kind of, that hold a certain amount of value. Here's the faceplate here in case the camera was over it. Okay, so essentially then what I'll do is I'll just kind of accept him, and then I'm going to go back, and so I've accepted him, and basically what I'm going to do then is I'm going to go into my application again, and I can see that all of the different variables have essentially opened up, and I'm going to go here then, and I'm going to trigger them back to 0. And here, actually, just before I do it, I'll see that the actual time to go back the way, if I can just give them a click there, to actually go back the way is 15. So I get 15 seconds to basically go back. So I'm going to go in here, I'm going to set them to the value of 0. And what I'll see then is I'll see 15 has come up basically as a time limit. And here I can see in real time, he's going to go from yellow to red. And essentially the second relay basically went off there. So it's kind of like that's a kind of a practical example where I basically am looking at these values have an impact essentially in real time. I think from myself for where I would want to kind of get these things right, I think ultimately, you might have a standard instrument index, and here's kind of an IO index where you say a call for certain variables and so on that can actually come up. My honest opinion on how to not end up with problems in this area, it's essentially kind of, for me, I think having an understanding of all of the parameters in IO indexes is definitely the way to go, and definitely during commissioning when you're actually going to execute, in real time, you need to make sure that all these variables are locked down, because then you can end up with a lot of surprises when you start actually getting into real logic, kind of out in the field, and that's kind of definitely my view on things. Thank you very much.